Hi there, and welcome back to Mathematical Misconceptions. Today, we are going to take a look at a very common mistake that algebra students do, which is when they add two unlike fractions, they tend to add both numerators over both denominators, and that simply doesn't work. And today, we're going to demonstrate this with a pie chart. We're going to pretend this is some pizza to see that when we add slices together, they should equal the total number of slices eaten. So if you're ready, let's dive in. Let's first define some of these numbers. We're going to start this by choosing some numbers rather than working through the algebra, and then we'll work backwards towards the algebra because I believe if we see this numerically, it's going to be easier to understand. In this case, let's go ahead and choose A to be 1. Let's choose B to be 3, C to be 2, and D to be 6. I think these will be easy numbers to see. So again, A over B plus C over D does not equal the sum of the numerators, A plus C, over the sum of the denominators, B plus D. Let's plug these numbers in. We're going to plug them into both sides to show this does not, in fact, work. A is 1 over 3, because B is 3, plus Charlie is 2 over delta, which is 6. And this does not necessarily equal the sum, 1 plus 2 over 3 plus 6. Let's go ahead and simplify things. Now we notice that this pie chart has 6 slices, and 6 slices make the whole. So what we're going to do is we're going to convert our first number, 1/3, to b over 6. And how do we do that? We need to multiply this number by a numerator and denominator that is the same, because if we multiply it by a numerator and denominator that's the same, it's going to reduce to 1. Therefore, it doesn't technically change the number, it just dresses it a little differently. In this case, we're going to multiply by 2 over 2. And again, if you're not sure you can do this, if you took this number and you canceled it out, you would just get back to 1/3. You're just doing manipulation so you can combine things appropriately. Now we have 2 over 6 plus 2 over 6 does not necessarily equal, let's go ahead and add these. So 1 plus 2 is 3, and then 3 plus 6 is 9. All right, now we can combine these numbers. So again, with like denominators, you can just add the numerators directly. 2 plus 2 is 4 over 6 does not equal 3 over 9. And to finally verify this, let's go ahead and reduce this as best we can. So we have 2/3 does not equal 1/3. And if you want to use a decimal, this is about 0.66, and this is 0.33. So these numbers clearly are not the same. Let's go ahead and color code the pie chart. All right, so let's say that the first person is the one who gets 1/3. So 1/3 of the pie is the same as 2 over 6. So we're going to shade 2 of these in red. Let's do 2 right here and 2 right here. 2 slices of pizza for you. And our second friend looked at this as an actual situation, seeing that there's 6 slices, and out of 6, they wanted 2. So we're going to do this in blue. And blue again. And when you add these up, it should be 4 slices of pizza eaten out of the 6 that were presented to begin with. On the right-hand side, we can see that this reduces to 1/3 or 2 over 6, which means if I were to shade this in a different color, let's say green, it would shade to 2 over 6. But that's just not how math works. We have to add things together because at the end of the day, if you have 6 slices of pizza, one person eats 2 of them, another person eats 2 of them, then 4 slices of pizza should be eaten. And if you want to see what remains, just subtract it from the whole. You have 2 slices remaining. Now we're going to go through the algebra. In this case, the algebra we're going to start with over here. We're just going to bring it over here. And we're going to give some space to begin with. So A over B plus C over D. Now, what are the rules with adding fractions? Well, the first thing you have to notice is that the denominators are not like each other. And the reason why here is because with algebra, we don't know what these quantities necessarily are. We have A over B plus C over D. The only assumption we can really make is that B and D cannot be 0. So let's just put that as a stipulation over here. Otherwise, you have undefined numbers, and we can't work with that. So what we have to do is we have to look at each fraction and ask ourselves what's missing from the denominator. And in this case, we have d missing right here. So much like what we did right here, where we multiplied by 2 over 2, we're going to take a look at that denominator over there and multiply this fraction by what's missing, d over d. Similarly, we're going to look at the second fraction and ask what's missing before we can combine it. So you have c over d, but this one has a b in the denominator. So naturally, what are we going to multiply top and bottom by? It's b over b. Now, if you're not sure you can do this, go back over here where you have actual numbers. What is 2 over 2 reduced to? 1, right? What does d over d reduce to? Also 1, which means that you're technically not changing the number, you're just dressing it differently. Same thing over here. What is b over b reduced to? 1. So we're just redressing things so that everybody is wearing a similar outfit, especially in the denominator. Now we can go ahead and combine these. So we have AD over BD plus, and then it's Bravo Charlie, BC, over Bravo Delta. And then what's the rules with numerators when we have like denominators? Add them directly. So we have AD plus BC over Bravo Delta. Now, of course, the best thing that we can do is when we have algebra and we're not sure what's going on is to verify with numbers. Let's take a look at these numbers again. So we chose A to be 1, B to be 3, C to be 2, and D to be 6. Let's plug them in on both sides right here. If what we're doing is correct, it should work out. So let's keep everything as is, no simplification yet. Let's just plug in the numbers and then we'll work through it. All right, so we chose A to be 1. So 1 times delta is 6 over, and then in this case we have Bravo Delta, so Bravo is 3 and Delta is 6. 3 times 6 plus Bravo Charlie, so Bravo is 3, Charlie is 2, over Bravo Delta. Bravo is 3 times, and then Delta is 6. After all, these two should be the same. Equals, and then we just do it again, Alpha Delta, 1 times 6 plus Bravo Charlie, 3 times 2, is all over, Bravo Delta, 3 times 6. Now let's just go ahead and simplify this. So I'm not going to strike out any common factors. We're just going to make sure that these numerators and denominators are consistent across the board. So we have 6 over 18 plus, and then 3 times 2 is 6 over 18, which should in fact equal 1 times 6 is 6 plus 6 over 18. And now that we see that, we can see that 6 plus 6 is 12 over 18. And in this case, if we were to reduce this a little bit further, we don't need to worry about the left-hand side over here. This should reduce to, so these have a 6 in common, so we can divide this by 6. We have 2 over 3, which is equal to 4 over 6, which is very similar to what we see right here. We have 4 over 6 in the original left-hand side when we reduce this, and this does reduce to 2/3, which is the same as that. When you're working with fractions, the thing that you want to remember is that when you're multiplying them and dividing them, they go by different operations compared to when you add and subtract them. When you add and subtract them, they must have like denominators. In other words, you have to redress fractions the same in order to add and subtract them. You'll need to be doing this throughout various algebra problems, especially when you get into Algebra 2 and above. All right, everybody, that was mathematical misconceptions with adding unlike fractions and some of the common mistakes that I have seen. If you have any questions about fractions or anything else, please drop them in a comment below. Otherwise, I'll see you in the next one. Thank you.